Hello, I'm Mr. Hotelling, and welcome to this installment of Numbers in Science. Today's installment is about bias and poor measurements. It's probably hard to believe that something that might seem as objective as making a measurement could have bias associated with it. So we have bias in measurements here, and our question is, how do we detect bias and poor measurements? What we'll learn: poor estimation skills leads to several types of biases: 0, 5 bias, non-zero bias, and non-5 bias. And we'll learn what all of those are today. These types of bias can be easily avoided by deliberate thinking. They can also be easily identified by close scrutiny. Over the years, I've come to be able to look at a student's set of data and tell whether they measured it carefully or not. And when in estimating digits, zeros and fives should appear no more often and no less often than any other digit. And we'll see the reasons for that in the coming slides. So first, let's talk about zero bias. Zero bias occurs as the tendency to assign estimated digits of zero. When we're estimating that next decimal place, to put a zero in place. So what that looks like is, let's suppose we have something that is really to here, or to here, or to here, or to here. And we just say it's 8.0. When in reality, it should be a 0.8 or a 7.8 or 7.9, or an 8.1 or an 8.2. So from that sense, it's kind of the result of laziness and lack of scrutiny. But it leads us to have less precise measurements. So this is zero bias, the tendency for zero to appear as the estimated digit more often than you might expect. So similarly, there's a 5 bias. Let's suppose we have something that is, in reality, is here, or here, or there, or there. Well, we might think then that if we were imagining that 0.5 mark, that it's there, to call all of these things 7.5, when really they are 7.4 or 7.3, 7.3 or 7.4 is more accurate than calling it 7.5. And similarly, it may be the result of something that should be 7.6 or 7.7 when it's really 7.5. And like the 8.0 bias, the zero bias that resulted in the 8.0, it's the result of not taking care or of a kind of mental laziness in estimating your digits. So that's the first level. When students are first learning to make scientific measurements, they tend to, more often than they should, report the 0 or the 5 as the estimated digit, which leads to more uncertainty and less accurate results. Now, for students that gain some experience, there is two types of bias, which is non-zero bias. And this is the exact opposite of what happens. That being aware of zero bias, that when things are super, super close or exactly on 8, we don't want to give the appearance of having zero bias. So we avoid saying zero bias, giving it a 0. And we say something like 7.9 when it should be really 8.0. But we're so desperate not to put the 0 that we actually don't assign the 0 when it should be. And it could be because it's under by a little bit, or it could be because it's over by a little bit. But it's when it should be 0, and because we don't want to appear as using 0 too much, we avoid signing it a 0 when it should be. And so, of course, the 0.5 bias is the same thing, where we have things that are really super, super close to or indistinguishable from being 7.5, and the result is we say 7.4 when it should be 7.5. And so that is, this is the non-5 bias. It's a tendency to avoid assigning those estimated digits of 5. So in the end, it takes us back to what we want to come away from. We want to be deliberate in our measurements, and when estimating digits, zeros and fives should appear no more often. That's the case of the bias we want to be careful. And no less often. So we don't want to avoid. So that's an avoidance bias. In either case, they are biases, and we want to be careful of them. And so a simple rule of thumb for ourselves is to ask ourselves, what is this really? Let's not be lazy and assign it a 0. Let's not be lazy and assign it a 5. But if it is a 5 or a 0, assign it and not be afraid. But we should be seeing 1s, 2s, 3s, 4s, 6s, 7s, 8s, and 9 as often as 0 and 5 as the estimated digits. In our next installment, we are going to look at calculations, addition and subtraction, our fourth type of numbers. There are 4 different ways we get numbers. The fourth of those, the numbers we see, are the result of calculations. And we will be looking at calculations and how addition and subtraction relate to those calculations.